Hello students, welcome to today's ecology class. Today we will discuss island biogeography. Have you ever wondered why one island is more populated than the other? There are various reasons behind this uneven distribution of species. Today in this lecture we will explore those parameters that govern island biogeography. Robert Arthur and E.O. Wilson are eminent ecologists who had developed the theory of island biogeography. The two most important factors that define island biogeography are distance of the island from the mainland and size of the island. These are the two most important factors which we will explore, and we will understand how immigration or entry and emigration or exit or extinction of species affect the island, or more precisely affect the population of the island. The balance between immigration and extinction of species gives us the equilibrium species. The mainland is the source of species. A large island close by can also serve as a source of species. The island on which a new fresh population is going to develop can be of two types: oceanic islands and continental islands. The oceanic islands are normally formed by volcanic activities, whereas the continental islands are formed due to the rise in water levels. Now, how will these type of islands get populated depends on factors like their distance from the mainland and their size. So let's start a discussion with two islands. One is nearer to the mainland while the other is far away from the mainland. Rate of immigration and emigration or extinction is plotted along y-axis, and number of species is plotted along x-axis. Using two different colors, we will now graphically represent the rates of immigration and extinction in near and far islands, as well as large and small islands. When the island is located closer to the mainland, then the rate of immigration is comparatively higher than that located farther away from the mainland. So, when we plot the graph for immigration, we see a curve like this. If the island is far away from the mainland or far away from the source of species, then the rate of immigration will be lower. For a near island, the rate of extinction is lower than that found on an island which is located far away from the mainland. So now let's draw the curve for extinction or the rate of extinction in far island and near island. So this is the curve that denotes the rate of extinction in near island. Now we'll plot the same for the island that is further away from the mainland. So here we see this is a curve for immigration, I mean the rate of immigration in a near island. So let's write that. Near island, and this dotted line is for far island. Now here we'll see this thick blue line is for the rate of extinction in near island, and this is for far island. Now we will find out the point which will denote equilibrium. Let's start with near island. The point of intersection of the blue and black curve will give us the equilibrium of species found in the island that is nearer to the mainland. So this is the point. Okay, this is the point. Now if we drop a perpendicular like this from this point of intersection, it is like this. Okay, this is the equilibrium species for near island, and here we see this is the point of intersection of the two curves for far island. So if you drop a perpendicular like this, it comes here. These two perpendicular lines will help us understand the number of species present at one point of time in near island and far island. This value or this point depicts that the number of species in near island is more than that in the far island. The point of equilibrium shifts towards the left when the island is located far away from the mainland. So this is how we graphically represent the number of species along with the rate of immigration and emigration in near and far islands. An isolated landmass or an island located near to the mainland has higher rate of immigration and lower rate of extinction. An island closer to the continent or landmass is expected to have greater number of species. This proximity to the mainland gives way for higher chance of species entry into the island. Repeated and steady rate of immigration saves a species from extinction. If the island is located far away from the mainland, the chance of immigration or the rate of immigration becomes very slow, and there are high chances that a species will get extinct. So an island nearer to the mainland is always at an advantageous position. Advantageous position in the sense it will not face extinction so easily. The species will not face extinction so easily. We will now talk about how size of an island affect island biogeography or affect the population in that island. Island A is smaller in size in comparison to that of island B. Though the two islands are equidistant from the mainland, the larger island will be having a larger carrying capacity and will be able to accommodate larger number of species. Resource will also be abundant, hence chances of extinction due to scarcity of resources will be lower. The rate of random dispersal is also comparatively less in the case of smaller island. When the habitat area is large, in case of a large island, the rate of immigration is high and rate of exit or extinction is low.